Poisson distribution is the another distribution that comes under the heading of discrete distribution. In a binomial distribution, when n is large, more than 20, instead of using binomial distribution, we will use another distribution, which is a Poisson distribution. The Poisson distribution is not a separately new distribution, is a limiting case of a binomial distribution. What limit is involved? Limit n is large, it means we can say that n tends to infinity on the binomial distribution. Binomial distribution Bx and P. Bx and P stand for binomial with the random variable x, and the value of n and the value of P are given. If we apply this limit n tends to infinity on binomial distribution, this will become the Poisson distribution. So we can represent that by B, X, and mu. Mu is what? Mu is the mean. Mu, as binomial have a mean of NP, then Poisson have a mean of mu. The mu is what? Mu is the mean of the Poisson model. If we apply this limit, then the function of binomial distribution will have another form. That form is known as the Poisson model. The Poisson model is this: e raised to the power minus mean raised to the power x divided by x factorial. X is what? X is 0, 1, 2, and a very large number. Maybe infinity in some cases, but if n is greater than 20 in binomial distribution, we prefer to use Poisson model. E is what? E is a constant natural logarithmic exponent, anti-logarithm of natural logarithm. In the value of this E is 2.71 something. Mostly this distribution was developed whenever the telephone industry was created. It is an ancient distribution, and suppose we have 1,000 choices for the telephone of color, type, option, portability. A company is opening a large regional offices, and each of its 200 managers is allowed to order his or her own choice of telephone. Which type of telephone is most preferable for the clients. Assuming the independence of choices and each of the 1,000 choices are equally likely, what is the probability that a particular choice will be made by none, 1, 2, or 3 of the managers? This is basically the model. As n is very large, we have to apply Poisson model. The probability of 0, how the probability of 0 is computed can be mean raised to the power. The mean of the distribution will be what? Mean of the distribution will be 200 multiplied by 1,000. This is the mean of the distribution, and this 0.2. And what is x? X is we have 0, we have 1, 3, or 4 different values of x. We have 0, 1, 2, 3, and so on. The probability of 0, how can we compute the probability of 0? E raised to the power minus x, e raised to the power minus mu, mu raised to the power x upon x factorial. E raised to the power minus mu, and mu raised to the power x divided by x factorial. So we can calculate the probability of all of these outcomes. Probability of x is equal to 0 is 0.818, probability of x is equal to 1, 0.163, and so on. Assumptions of the Poisson model. Mostly all of the assumptions of binomial distribution is same as the Poisson distribution, except only one, that n is large. The probability that an event will occur in a short interval of time or a space is proportional to the size of interval. In a very small interval, the probability that two events will occur is closer to the zero, the probability that any number of events will occur in a given interval of interval is independent of whether the interval begins. The probability of any number of events occurring over the given interval of is independent of the number of events that occurred prior to the interval. That are the basic assumptions of Poisson model. If mean is 1, we have a number of rectangles which are very broad too there. If mean is 1.5, the smaller rectangles we have. If mean is 4 and the mean is 10. If mean is 10, we have approximately symmetrical shape. The mean, if mean is small, then we have a right skewed distribution. If mean is 10 or more than 10, we have a continuous, we have a bell-shaped distribution. Here is a comparison of binomial and the Poisson model. The trials are independent. Yes, the trials are independent in case of binomial distribution, and as well as the trials are independent in case of a Poisson distribution, because the trials are independent means what? If the probability of success at trial number 1 is same as the probability of success in trial number 2 and so on, the probability remains same from trial to trial. Are the trials fixed in case of the binomial distribution? Yes, the trials are fixed, and that are fixed before starting the experiment. N times. Trials are fixed in Poisson distribution, but is very large. Infinity is not, it is theoretically infinity, but it may be 100, 200, and so on. Is P remains fixed from trial to trial? Yes. In case of the binomial, as well as in case of the Poisson distribution, the P remains fixed. P remains fixed gives us the independence in trials. Means the probability of success in trial 1 is same as the probability of success in trial 2 and so on. In binomial distribution, we have two parameters. One is N and other is P. In a Poisson distribution, we have only parameter, which is lambda or mu. We can write down either lambda or mu. Mu is the parameter, and mu is basically equal to N times P. So if we multiply these two parameters with the binomial distribution, then we have a lambda and mu both are same. Either notation we can use. In the previous slide, I used the notation of mu instead of lambda. Notations of binomial B, X, and P. Parameters are separated by comma. If we have the 2 or 3 parameters, then parameter number 1, which is N, parameter number 2, and variable and parameters are separated by semicolon. B stands for the binomial. The binomial distribution can be described by B, X, N, P, while Poisson distribution can be represented by X and lambda, or X or mu. We can also represent this as P, X, mu. If we are representing the parameter by mu, then the notation will be this. Otherwise, we can use as Px. Mean of the distribution is NP, the mean of the distribution is lambda or mu, the variance is NPQ, the variance is lambda. So one of the important characteristic of Poisson distribution is that mean and the variance are same in case of Poisson distribution. The mean and the variance are same. The mean is equal, variance is the one of the very important characteristic of Poisson distribution. Now we have a concept of discrete and continuous. As I told you earlier, discrete distribution can be represented by a table, while continuous distribution cannot be represented by table. Probability distribution in case of discrete, if it is represented by a formula or a function, is known as probability mass function, while the distribution of continuous random variable is represented by probability density function. The PDF is one of the important terms which is generally used for a continuous distribution. Discrete to continuous, what is the major difference? In discrete, we have intervals, discontinuous intervals. While we have an area. The major difference between the discrete and the continuous distribution is that in discrete, we have probabilities at the distinct point. The probability at 1, the probability at 3, the probability at 7. These are the single values of the probability. While in case of continuous distribution, we have the area in between the 2 points. So if we are interested to compute the probability from 2 to 3, the probability from 2 to 3 can be represented by integral from 2 to 3 of this function. The function, suppose this function is px multiplied by dx, because whenever we are integrating, we have integral. So what is px and dx? Px is basically the height of this rectangle and dx is the width of this rectangle. So this is basically the area of one rectangle in this. And if we are summing the area over the whole rectangle, this is integral. The integral means what? Integral means the sum. The summing the area of all of these smaller rectangles will give us the area of the entire region from A to B. So that is the main difference between the discrete and a continuous distribution. Continuous random variable have probability function which is greater than 0, means probability function can never be negative, and it has a total area 1. Total area 1 means what? Total probability is 1. And cumulative distribution is a distribution which is represented by capital Fx, and it is the sum of all probabilities from lower limit to a point which is x. So if we integrate a probability density function from lower limit to x, then this will be the distribution function. The distribution function is used whenever we will continue our discussion in a normal distribution, because normal distribution is the table of the normal distribution is represented by a distribution function, not the probability density function. The areas are represented. This is the graph of our distribution function, because distribution function, the probabilities are greater and greater and greater and will be equal to the 1. Then when it reaches to the 1, it will becomes flat. The curve becomes flat. The probability between A and B can be computed by FB minus FA. FB stands for what? FB is the area up to here. This area is FB. This is FB. And what is FA? FA is this area. If I subtract the FB means this area and FA this area, then the shaded region, the blue region, we have the area. Instead of integrating, we have a subtraction. If we have a distribution function, then area can be computed by subtraction. A very simple way of computing the area in case of the continuous distribution, we have to just subtract the two numbers if we have a distribution function. Uniform distribution. Uniform is a continuous distribution. Now we are switching our discussion to the continuous distribution. Two distribution I will discuss. One of them is uniform distribution, and other of them is a normal distribution. In a uniform distribution, the probability function is 1 upon A minus B. 1 upon, not A minus B, 1 upon B minus A. This is the distribution. 1 upon B minus A. This distribution is known as uniform distribution and is a continuous distribution where X lies between A to B. Both inclusive. A to B, both limits are inclusive. So this is not A minus B, this is basically the B minus A. Now the mean is A plus B divided by 2. The graph can be represented by such a way we have a uniform distribution. The probability of a uniform distribution can be computed by 1 upon upper limit minus the lower limit. This distribution is known as continuous uniform distribution. Uniform distribution. Suppose uniform distribution in the limit of 0 to 5 is equal to 1 upon 5 minus 0. This is fx. 1 upon 5 minus 0. This is the distribution probability density function of a uniform distribution in an interval of 0 and 5 inclusive. Square bracket means what? The intervals are inclusive. The mean is 2.5 and the distribution is represented by this way. Now a complete case of fitting of binomial distribution is under consideration. In this table, the sample of 128 is given. We have to fit a binomial distribution and then we have to find the mean and standard deviation of the fitting distribution. Fitting of the distribution, there are some steps involved. In the first step, you have to estimate the parameters of the distribution that we have to. So N and P are the two parameters in a binomial distribution. We have to estimate these two parameters. After estimating these parameters, we have to compute the probability of all of these outcomes and then multiply these probabilities with the capital N. Capital N is basically 128. So capital N is 128. In the first step, we have to estimate these parameters. One is N, other is P. These two can be estimated. I will do this entire example in Excel. Now the data is taken into the Microsoft Excel. The two columns are here. And the first step is to estimate the N and P. How N and P are estimated? By mean. So we have to construct a column which is fx. How fx is constructed? Fx means the f times x. Fx is the product of the frequency with the variable x. This is in Excel, that can be obtained by this multiplied by this and taken the sum downward. The total will be calculated. Total can be obtained by just clicking on the sum button. Sum will be sum of fx is there. If the sum of fx is there, the sum of f is also required. It is 128 because the total observations are 128. Now mean can be computed. How the mean can be computed? The mean is equal to summation fx divided by summation f. This is basically. Now the mean of the distribution is computed by summation fx divided by n. How the formula of mean? Summation fx, because it is the mean of the group data. Summation fx divided by summation f or n. This is the formula of computing the mean. After computing the mean, what is required? We have to estimate n and p. How the mean? How to estimate the n and p? We will write down x bar to be equated by NP, because the mean of the binomial distribution is NP and the mean of this data is x bar. This is x bar and we have to equate them. So x bar is equal to the NP and now it is 3.38 the mean. And the value of n is 7 because 0, 1, 2, 3, 4, 5, 6, 7. The value of n is 7 and p is unknown. Then p can be obtained by, this is the estimated value of p. The P can be obtained by 3.38 divided by 7. If we divide them, this is equal to 3.38 divided by 7. This is the value of P. And this P will be used for finding the rest of the probabilities. The P is 0.4826. Now the probabilities of the binomial distribution can be computed by the formula Px NP is equal to NCX P raised to the power X and Q raised to the power 1 minus X, N minus X. This is the formula of computing the probabilities of the binomial distribution. I am going to implement this formula into the Excel and using the value of P as 0.4828. So now the probabilities are here. Probabilities Px is equal to NCX. NCX means what? Combinatorial. COMBIN. All of you are familiar with this formula of finding the combinatorial in this. And the value of N is what? NCX 7 combination. And X is what? X is this number. 7C0 P raised to the multiply by P raised to the power 0. The value of P is what? Value of P is 0.4828. So I'm just using as a static value here 0.4826 multiply by Q. Q is what? 1 minus 0.4826 raised to the power N minus X. Raised to the power N minus X, 7 minus X. X is what? X is this. And this should be in bracket. Power N minus X, as well as we have the here power X. Power X is this. This is the first value of the probability. I am just reviewing the formula. I am reviewing the formula. Combine NCX. N is 7. X is the 0. First time it is 0. Then P raised to the power X. P raised to the power X. That is not shown here. So I have to edit the formula. P raised to the power X. Then this is X. P raised to the power X. Not correct. I have to review the formula again. Now you can see the complete formula. Combinatorial NCX. 7 combination X. X is A6. Then P raised to the power X. P is 0.4286 raised to the power X. And 1 minus X, 1 minus P, which is Q. Q raised to the power N minus X. Again, I use 7 minus A6. This is the formula of computing the binomial probability. This probability is to be computed for the rest of the values of X. This is second value, third value, and the last value. These are the probability. If I sum these probabilities, then total will be 1. So I'm checking this whether total is 1 or not. If it is not 1, then it is exactly 1. Means the probabilities are correct. So this is the first step. In the first step, we have to estimate the value of P that can be estimated by equating the mean of the theoretical distribution and the observed distribution. And then by equating them, we will get the value of P. After getting the value of B, we have to find out all probabilities using the binomial formula. Now we have to find out expected frequencies. These are referred to as F in the subscript E. F in the subscript E means what? F in the subscript E means we have to find out the expected frequencies. In the subscript, we have E here. So this is something different with this F. This F is known as the observed frequency. I can write down the FO here. FO stands for the observed frequency, and FE stands for subscript. This is FO. Now FO and FE, these are the two columns. FO is the observed frequency, FE is the expected frequency. The objective of fitting is to find out the expected frequencies. How the expected frequencies are computed? A simple formula it is n times probability. What is FE? Formula of FE. I am writing the formula of FE here. N times probability. And which n is to be used here? 128, because this is capital N, which I have to use here for finding the expected frequencies. So I am here. We have 128 multiplied by the probability. This is the first expected frequency, and the remaining expected frequencies can be calculated in the same way. Then we can round them, because frequencies should be in whole numbers. So this can be rounded by 1.26 can be represented by 1, 8.2 can be represented by 8, or either we can use the round function. How the round function can be used here is equal to the round in the bracket. We have to specify the number which is to be round, this one, comma, how many digits we are going to round? 0 digit, means it is 1. Now it is 8, now it is 223, then 36, then 33 becomes 34, and then 18.8 become, and so this wrong, 30, no, is not correct, 36, then is to be copied here, 34, then remaining in the same way. Now total should be how much? Total should be approximately 128. So I'm placing the total here. Total of 128. These are known as the expected frequencies. So this process is known as observed frequency. So what was the observed frequency? The observed frequency was 7. First observed frequency. I'm just checking it again because I have some doubts on it. Expected frequencies are ultimately obtained, but there should be a difference. There is a difference. This difference is not very appropriate, because the big difference we have in the observed 7 and expected 1, observed 6, expected 8, observed 19, expected 23, observed 36. There is only one frequency which is more close, that's 35 and 36. Other than that, we have a high differences among the different expected frequencies and the observed frequencies. How the fitting is a good fitting or not a good fitting, that can be decided with the help of similarities between the observed and the expected. If the observed frequencies and expected frequencies are similar, then we can say that the distribution are very accurate fitting we have. If these two distributions having a high differences, then that is an indication of a poor fitting. So we can say that this binomial distribution is not accurately represented by this observed distribution. There is a difference between the
two frequencies. If these two frequencies are identical or very close to each other, then we can say that observed frequencies and expected frequencies are have similarities, and we can say that this observed distribution can be represented by this step is known as model test.